Hello. Good morning, everyone. Am I audible?
Good morning, sir. Good morning, sir. Hello. Good.
Participants will be starting our session we shall be starting our session in next 5 minutes. So, very good morning to all. And on behalf of the organizing committee of ICACFCT-2021, myself, Shashwat, is going to welcome. I take this pleasure to welcome our guests of honor and a keynote speaker for today's session, Dr. Miet Meerut sir. Dr. Miet Meerut sir is the professor in the Department of Electronics and Communication Engineering at Motilal Nehru NIT Allahabad. Sir has been actively involved in the core research of communication and especially the wireless communication. Sir has expertise in doing research on the physical layer of communication, which is also related to the RF, microwave, and antennas. Sir's students have been actively publishing the papers in the reputed international journals, and Sir has been doing the projects from the government of India and state government related to the medical applications of RF and microwave devices. So without wasting much time, I am welcoming Professor Miet Meerut sir to enlighten our audience. Welcome, sir.
Thank you, Dr. Shashwat. I am thankful to the organizing committee for inviting me, for giving me this opportunity to share some thoughts related to this conference. Let me share my slides first.
It is visible, sir, now.
Okay, thank you. The title that I have selected for discussion today is on RF and microwaves in biomedical applications. As we know that RF and microwaves are basic constituent of communication system, wireless communication systems. But this is a different dimension of using RF and microwaves in human health applications. There are basically some 4 or 5 categories of human health applications: imaging, testing, scanning, and rehabilitation. First 3 are related to the diagnosis of particular disease, and one is related to treatment and rehabilitation of the patient. There are numerous methods to do this diagnosis part. There are very many conventional methods. Among those conventional methods, you must be aware of ultrasonography, USG, ECG, CT scan, MRIs. Some are using mechanical waves and some are using these electromagnetic energy. They are all using energy in one form or the other. That is the elementary constituent, that is the common thing between them. If we think in terms of this RF and microwave in medical applications first, it all started with the replacing this wired links by wireless links. These wireless links were used in ISM band, industrial, scientific, and medical band. So they were limited in terms of power and in terms of the data rate. The data rate was very low, and the power level, which is basically related to distance required for transmission, means distance between the separation between transmitter and receiver. But unfortunately, there were several regulations which are basically related for wireless communication, not for wirelessly data transfer of medical data, which was very data intensive sort of system. So the band also, the frequency band which was prescribed for medical applications, the modulation standard that were selected for different networks in IEEE standards. So they were all posing challenges in using this RF and microwave systems in medical applications. In terms of standards, if you think, there are basically two very popular standards, IEEE 802.15.4 and Bluetooth low battery, low energy, BLE, are two standards which are being implemented for wireless medical devices. This is a set of development which is being in pictures since past decade. It is not a very new area. People are working with partial success in different in replacing different sensing, data transmission, and treatment procedures using these RF and microwaves. Some are successful, some are not successful, and but those which are successful are very much popular in terms of their application. There are numerous commercially available products in the market globally. There are global presence of various products from Murphy, from NXP Semiconductors, from Plessey Semiconductors. Plessey has developed EPIC sensor technology, which it is miraculous thing. You must have heard of ECG, which is taking electrical measurements from different nodes which are put on the different body parts, and it takes microvolts sort of electrical energy and draws the plot of of heart's activity in terms of ECG. But this EPIC sensor technology is taking a simple probe, a set of sensors, and it places it above the body, and without any, this is a contactless ECG system. It does not require any physical or resistive contact to make all these measurements. And this is a miraculous, successful sensor. A set of new products are expected to be developed in terms of medical scanning. So my talk today will be having some 4 dimensions, some introductory notes, then biotelemetry, medical diagnosis, and medical treatment. These 4 dimensions are I'm sorry, by mistake it is repeated. It is medical treatment. The fourth one is. This is my mistake. See, the biomedical field is human health systems are overloaded because of population growth and corresponding increase in number of patients. There is a variety of health problems, and coupled with relatively less number of health workers, we need to have novel ideas to solve these health related issues. And treatment as well as monitoring of human health is a challenging task. Because of various issues involved, the issues which are involved are in terms of regulatory demands and the time that is needed to solve these issues. The regulatory demands actually from different governments, they require that this system which is developed for a particular human body is not harming particular human being. It is not harming the tissues, the cells, either in terms of ionizing radiation or in terms of some increase in temperature. So every time, whenever a new product is developed, the regulatory authorities recommend certain modifications, certain alteration, and it requires time. Then there are several other issues which are technical in terms of in nature. The waves which are broadcast from an antenna or from which are being reflected from different tissues, bone, blood, or refracted within the medium, should be minimally interfering. There should be non-interference of waves or minimal interference of waves. Then there should be the products that are developed should be standards compliant. Then there are number of design requirements in terms of power and in terms of frequency. So all these challenges are to be tackled by this RF designer. The technologies that are being used are basically supported by FPGA technology coupled with flexible integration platforms. So people develop the prototypes on the basis of the new tools. These tools were not available some 30 years back, although this area is very old, but the tools which we have at our disposal are relatively new. And on the basis of these new tools, that is modular FPGA hardware, higher level design tools, industry standard platforms, number of simulation tools, number of emulation tools are there. And researchers tend to design very flexible products. Sometimes they become successful, sometimes they fail in their design, and people try to reinvent it, reformulate the basic designs. Let us have a quick view of the conventional technology. The magnetic resonance imaging, which we are using, magnetic fields are very popular, very useful systems. Then CT scanning, that is mammography and computed tomography, X-rays, sonography using ultrasounds. All these are widely used technologies for diagnosis of particular diseases. Now, when we have, question is, when we have this conventional techniques, what advantages microwaves provide? They are basically, they can be divided into three categories. Microwaves gives us a wide range of frequencies, megahertz to gigahertz. So what? It can provide very good accuracy. You can go for very good amount of precision. If you increase the frequency, your precision increases. This is the common notion in sensing. Then there is a wide range of application in different fields: military, transportation, defense, agriculture, medical. And in particular medical, it can be used for blood glucose sensing, it can be used for cancer treatment, it can be used for heat treatment, and it can be used for data transfer directly. And microwaves support, they are basic constituent of wireless technology. So it is not the case that there is a sensor which is sensing on the basis of some mechanical energy like sound energy, and then it is converting it into electrical energy, and then it is transmitting. The whole thing is a single ecosystem. So these are a few advantages of using microwaves and RF waves. Some of successful applications of RF microwave technology in biomedical field are shown in this slide. There are microwave sensors to sense various features of the body. There are implantable antenna. There are capsulated antenna, and there are different catheters developed in the form of microwave balloon catheters in order to sense various parameters of the body. Some additional advantages are listed here. In conventional scanning systems, they use ionizing radiation like X-rays, may be harmful in terms of risk of cancer because of this radiation is ionizing. In RF and microwave, they are using non-ionizing radiation. They are lightweight in contrast to bulky machinery. If you have seen this MRI or CT systems, they are not usable in rural or in remote areas. The cost of manufacturing and operation is relatively lower in microwaves and RF systems. A very important advantage is that the RF and microwaves have very good penetration ability into all types of human tissues, including bones. So we can detect various abnormalities within the bones itself using RF and microwaves, which is not possible using mechanical waves. The frequency bands which are used in biomedical applications are of 4 categories. First category is MED radio, medical device radio communication service band, which is 401 to 406 megahertz. Then MICS band, medical implant communications service band, 402 to 405 megahertz. ISM band, and within ISM band, this 2.4 to 2.48 is relatively more popular band because there are various other useful protocols developed around this set of frequencies. Then WMTS band, wireless medical telemetry service, 600, 1.4 and close to 1.4. Now, a very significant question comes into our mind. What is actually sensed using this RF and microwave in our body? And its answer lies in electrical properties of human tissue. The human tissue has certain electrical properties in terms of permittivity, conductivity, loss timing, and it varies with frequency. The RF and microwave devices are placed near to human tissue, and it actually measures the relative permittivity and other electrical properties of the human tissue. And on the basis of any variation, its abnormalities, that is the abnormalities within the tissue, are sensed by the system. For tissue safety, specific absorption rate is measured, and specific absorption rate is a safety measure basically for evaluating heating effect of electromagnetic waves on human tissues. Elementary definition is the power absorbed per unit of volume in biological tissue. Magnitude of E field is squared multiplied by conductivity and divided by the mass density. This is SAR definition. As per the standards of IEEE, for 1 gram, SAR less than 1.6 watts per kg. And in another standard, relatively newer one, for 10 grams, SAR less than 2 watts per kg is standardized. And all the designs in this domain should follow, should be below this SAR level. I have tried to categorize the microwave applications in 3 categories, although there are various application areas, including data transfer, external heat treatment, electrosurgical tools, minimally invasive endoscopic cancer treatment or RF ablation, sensing, imaging, scanning. I have tried to categorize them in biotelemetry, diagnosis, and treatment. In biotelemetry, there are 3 research areas which are relatively new. Implantable systems, wearable systems, and encapsulated systems. Implantable means the system, the RF system is implanted within the body. It is implanted within certain human tissue. Wearable means the device is over the body. It forms the part of wireless body area network. And encapsulated means it is ingested. Very small RF system is developed, which is ingested by the patient. It goes into the within the body. It travels across the body and moves out of the body after some 12 or 13 hours. And during that journey, it senses various parameters and gives us its measurements. The second aspect is diagnosis. Cancer and tumor detection is a very important parameter. There are various other diagnosis parts also, but I have not included them because they are not very much successful till now. This cancer detection, particularly breast cancer detection, is very popular area in which they are successfully designed commercial products. Early cancer detection products are already available in the market. And its basic principle is same. The electrical properties of normal tissues are different to cancerous tissues. And our sensor senses this difference if it is sufficiently sensitive. And based on that, the location of tumor, the type of tumor can be detected. Then third one is treatment, which includes hypothermia, that is increasing the temperature of a certain set of tissues so that they die out. Microwave ablation is another method in which cancer treatment is performed. This diagram describes what is the set of possible applications related to these RF systems. These are various wearable and implanted devices. In figure 2, implanted sensors are shown, in which a sensor system is implanted within the body, and data is taken wirelessly from certain external sensor. It is processed, and based on this processing, it gives signal to the controller within this body. This is particular example of hello. Yes. This figure 3 describes EBG antenna. Again, figure 4, implantable antenna, and so on. In biotelemetry, wireless data transmission is performed between these implanted medical devices or wearable or encapsulated devices to external devices. Here the design concerns are transmission of data from patient to an external sensor. And the basic purpose is accurate and real-time data transmission to improve the quality of life of the patient. Antennas can be placed within the body for glucose monitoring of diabetes patients, cochlear implants in between the ear for hearing impaired, for deep brain stimulation as shown in this diagram, or for intracranial pressure monitoring. Intracranial pressure is the pressure exerted and sensed by this fluid which is within the brain, within the skull of the brain, within the skull. And this pressure increases whenever a patient faces certain trauma. And monitoring of this ICP is very important. There is no mechanical mechanism available for medical practitioners to measure this intracranial pressure, because the skull is a very closed part, and once the patient is under trauma, he has met some accident, and the doctor has to say what is the condition of his swelling in brain, and it is directly related to this intracranial pressure. So there is one opening in terms of eyes. So people use the eyes USG ultrasonography, and based on those measurements, they guess that there is certain high ICP or normal ICP. This thing is replaced by successfully replaced by these RF devices. A very small system of RF is placed within the skull, and it directly gives the reading of pressure. Similar application is deep brain stimulation is also observed, and it has been developed in by numerous research groups. For biotelemetry, this model of implantable system can be shown by one model. There are numerous models, but this is the simplest one. There is a base station, which is directly connected to human body. RF system is placed within the body. For example, the pacemaker can be placed within the body. It is directly connected to certain base station. And based on the measurements, which is based on the data which is provided by the pacemaker, this controller gives certain commands to the system. To this implantable system, there are certain components, certain blocks, basically insulations, implantable antenna. There are electronics and power supplies which are placed within this box. Then various biosensors and bioactuators are placed within this packaging. So antenna takes and gives data. Biosensors takes data from human body. Actuators take command from base station and accordingly give certain control signals to various tissues of the body. This is a very brief idea of implantable system, particularly for biotelemetry and various similar applications. As far as antenna design, we are basically in RF systems. We are concerned with antenna design. So we will focus in this part. What are various issues related to antenna design? It is very important that the antennas are surrounded by human tissue. So this is a very different type of challenge. The environment within which this RF signal source is to be working is different from our normal cellular system antennas or laptop antennas. They are all working in open area. But when you have to design implantable antenna, you have to think in terms. If it has to work at certain subcutaneous level, in that case, its power level is not that important. So various design parameters in terms of power and in terms of frequency for proper penetration are important. Other challenges are safety of patient, small antenna, it should be miniature and compact. SAR value should be low, wide band of operation, because you don't know how this tissue will behave and how much frequency will be deviated. Polarization should be circular so that proper communication can be established, and high radiation efficiency and gain. They are very common design issues. There are a number of papers in this area. I have taken some 3-4 papers. Syed Ahsan Ali Shah. They have designed this antenna for scalp implementation. It has dual band characteristic, and as you can see, the certain time type of patch is used in its design. Number of parameters which are acceptable within the range are given. Second paper that is of interest is by Ijaz Ali Shah in 2019. They have developed for scalp implantation as well as for leadless pacemaker systems. They have again designed a patch antenna, spiral shaped, and multiple bands are they were able to develop. They were able to generate number of waves, number of bands. It could support a very good range of data rates. And its size was also very small. Then Farooq Faisal, IEEE transaction on antennas and propagation in 2019. Scalp implantable antenna was proposed. It was designed for ISM bands. Then Muhammad Jada, he has also developed similar type of antenna, but he has used this metamaterial loaded in the patch. Loading of metamaterial has increased the gain. Then one paper by Piyush Kumar Mishra. He has developed skin implantable patch antenna for various biomedical applications. Basic purpose was to for ICP intracranial pressure measurements. This paper is basically only simulation part. For measurements of implantable antennas, when we fabricate it, we go for either saline solution, in which 0.7% salt is taken with deionized water, or we can go for skin mimicking gel, in which gel is prepared with 53% sugar, 47% salt, and 1 gram agarose powder. They can use minced pork or rat tissues for real life like measurements. Next dimension is wearable or on-body application. The devices are used to transmit the data, which are being sensed either from wearable or from implantable devices. The major applications include temperature, body blood pressure, glucose concentration, respiration, and heart beating. Commercial products are available in for some of these applications 10 years back. For example, this blood glucose monitoring system, in which one invasive system has been replaced by non-invasive blood glucose monitoring system. Antenna is placed above the skin and below the skin, as shown in this diagram, and there is one antenna transmitting in transmitting mode, another one is in receiving mode. The waves are generated, they travel across the human tissues through skin, fat, blood vessels, again fat and skin, and reach at the receiving antenna. So based on blood glucose level within this blood, the electrical properties of these blood tissues change. And we try to make the sensor system with so much precision that this blood glucose level can be measured directly. The sensitivity of antenna towards glucose variation was studied very thoroughly. Different models, mathematical models, different practical curve fitting models have been developed. One of them is Cole model, which was given some 10 years back. And based on this Cole model, they have developed numerous antennas. This system by Mr. Shaukat Ali, the UWB antenna was developed. Maria has developed another antenna. This is a paper from our group. Saurabh Raj has developed an antenna in which split ring resonator is loaded on truncated patch for better gain. And this could measure with sufficient accuracy. They have designed and fabricated this antenna. It was tested using practical applications. And you can see that when relative permittivity of the blood changes, the resonant frequency changes. And based on this variation in resonant frequency from S11 graph, this blood glucose level can directly be observed. Then encapsulated applications of RF and microwave systems. have been developed in which the devices can be swallowed directly to transmit the data from liver and stomach. It is used in endoscopy applications. The patient ingests these systems. A very small antenna in which optical dome, lens holder, short focal length lens, LEDs, CMOS images, batteries, and radio telemetry transmitters and antenna are placed in this complete opto RF system. And this traverses across the body. The measurements are taken from an external sensor which is placed close to body. This is again a very successful type of product. Then medical diagnosis is the second dimension of our application. It is based on the concept of observing the scattered signals, which is caused by the dielectric contrast. This is the difference of dielectric properties between malignant tissues and the surrounding healthy tissues. So dielectric contrast is observed using our RF systems. There are two main approaches. One is radar. The radar approach means the transmission of signals and receiving back by the same system. Radio detection and ranging is used. Basic principles of radar is used in this radar imaging. Microwave tomography is another approach. Detection of not only breast cancer, the detection of stroke is also possible using these approaches. Water accumulation in human bodies can also be sensed using this type of diagnosis systems. EEGs can be also be performed using such principles. People are focusing in various research groups are there which are working in this area, and they are trying to develop new products. Last dimension is related to the medical treatment. The idea is to generate heat by microwave radiation. And this heat destroys the abnormal tissues. For example, malignant tissues can be destroyed. An RF antenna is placed, and you know the principle of microwaves. The water gets resonated and it gets heated up. Temperature increases. This temperature is sensed by the system. It reduces the power. Antenna reduces its radiated power, and so on. These systems have been developed with 1300 watts power of RF for heat generation. Some European medical companies are very much active in this area. Hyperthermia therapy is one possible treat the patient. The performance of this RF hyperthermia system is proportional to the energy transfer into the targeted region. The papers which are being developed in this area are by Bhaskaran, in which he has developed a phased array antenna for the purpose of this breast cancer treatment, breast cancer detection and treatment both. The localization of this is very important, and this is done by this Muntoni paper. Then a 2017 paper by him, they have developed another set of antenna systems in which hyperthermia applications at superficial depths within the body are considered. Another recent development in terms of this RF microwave application is microwave ablation. In this type of applications, the antenna is placed directly into the tumor. Liver tumors, lung tumors, renal and adrenal disease, bone malignancies, and similar other abnormalities can be taken care of. Radiofrequency ablation is a minimally invasive treatment for cancer. Basically, it is image guided technique that uses heat to destroy cancerous cells. But before that, it has to use ultrasound, computed tomography or MRI to help guide the needle electrode into this tumor. This RFA passes high frequency electrical currents through the electrode to ground pads which are placed on the body. So this creates focused heat, and this destroys the cancer cells surrounding the electrode. If we focus on different research issues for antenna design, these are latest research issues are numerous, but I heard only 3 of them worth sharing. Dielectric resonator antenna, metamaterial based and metasurface based antenna, and electromagnetic band gap based antenna are being researched by the researcher because of their some certain specific properties. We need to ensure small size, we need to ensure better precision, accuracy, and we have to ensure this standard conformity, standard compliance. And these antenna systems are relatively useful in these 3 dimensions. So I have tried to cover certain thoughts on this topic on RF and microwaves in biomedical applications. The credit of these slides are to Mr. Saurabh Raj and Mr. Piyush Kumar Mishra and my other students. The courtesy that should be given to internet resources, various IEEE journals, and certain cases also. I would like to thank all of them. And thank you all for patient listening.
Thank you so much, sir. And it has been really a very, very knowledgeable session. And we are really thankful to you. And because this keynote will definitely put an insight, and it will definitely help the students to understand what are the emerging and what are the exciting fields related to electronics and communication engineering, computer science applications which are there for the benefit of humankind, and especially in healthcare domain, which is overburdened and very stress domain. Thank you so much, sir.
Thank you. Thank you.
Thank you, sir. So I take this pleasure to again start our next technical session, sir, here. And we have Mr. S.K. Agarwal, the product manager from Interpol Technologies, and Mr. Aravind, who is also his associate related to this Interpol Technologies. Interpol Technologies has been very well associated with leading technical institutions of the country, and helping the researchers uh, actually transform their ideas, transforming their algorithms, validate them, and helping them transform, do the verification of their algorithms and develop in R&D. So without wasting much time, I'm welcoming Mr. Arvind Natarajan and Mr. S.K. Agarwal, sir. Welcome, Arvind.
Thank you, sir. Thank you so much. Shall we start, sir?
Sure.
Yeah. Okay, sir. Thank you. Let me share my screen.
Yeah, you can start sharing your screen.
Sir, is my screen is visible?
Uh, the process has started. It's not come up yet. You can stop and we'll start sharing again. Yeah.
Sure, sir.
Yeah, it's visible now.
Okay, sir. Thank you. So, very good morning, everyone. So, I'm really thankful to giving such a wonderful opportunity to present the Internet of Things in your conference. So, let's get started. So today we are just going to see the Internet of Things, right? What is Internet of Things? Just the basics, and what are the applications that comes under Internet of Things. So this is our today's agenda. Let's get started with the Internet of Things, introduction to Internet of Things, and why the Internet of Things is important, and what is the industry growth, right? Especially in Internet of Things, and who are the major players, and what industries can benefit with the help of the Internet of Things, right? And after that, let us go through the different layers which is there in the IoT ecosystem. Then finally, let us see the different applications across various industries, right? So this is our agenda today. So before we are getting into the topic, I would like to give a brief about the Intupl Technologies. So Intupl Technologies, we are a design services and product development and engineering solutions provider with cutting edge technologies. So we have our presence over 10 plus years, and we have 120 plus team members. We have 150 plus corporate customers and 1,500 plus academia customers, and we trained around 4,500 plus students for last couple of years, and we have certified top 25 simulation solution providers in the year of 2017. We are these are the different domains that we are specialized in. So we are into mechanical, CFD, PCB design, cybersecurity, Internet of Things, etc. So these are the different markets that we are operating in. So we are into an aerospace and defense, we are into public sector units and automotive. So we are supporting the research labs and the trainings, especially we have a dedicated team for academia as well. So with that introduction, let's get into the topic. So Internet of Things. So I would like to hear from any one of you. So before we are getting into an Internet of Things, let's talk about Internet of People. So what do you think Internet of People is? So can I get any answer? Anybody? So what do you think Internet of People? So before, for last couple of years, we are communicating to the people, right? So over the internet, correct? So that's basically Internet of People, right? So as a people, we are connecting to other people. right? How do we connect? With the help of the internet. So in this communication, as a people, we are connecting to other people with the help of the internet system, so that we could say internet of people, right? So it could be any medium. You can make a message, either the WhatsApp, Facebook, all these are the social medias we used to call it, right? So that's not the only way we can connect to the people. We have an email, right? So there are other platforms also where we can connect to the other people from the different parts of the world over the internet, right? So that connectivity basically we depends on the internet, so that we can say internet of people, right? In the same way, now let's think about internet of things, right? So internet of things, we can say connected things, right? Because internet of people, we are saying connected peoples. As a people, we are connecting. At the same way, in internet of things, the things that are connected to each other, right? So things that is connecting to other things, which is nothing but internet of things. So here the question is, what are the things, right? So is there any restriction for the things? No, right? As you can see over here, it could be anything. It could be your mobile phone, right? It could be your pressure cooker, your refrigerator, washing machine, right? Your computer. It could be anything, right? Any physical object which has some set of embedded system within it, that can able to connect to the internet, that can able to sense some information from its atmosphere, and that sensing information can be transferable to the other devices, right? So just like how as a people we could sense what is our surrounding, right? We could sense by looking at it, by hearing something, and we can transfer the same information to the other people, right? Either by meeting directly or over the internet, over the phone call, whatever it could be. So these physical objects will be transferring the information with the help of the internet, where it is connected to the other devices. So I hope you now you all are getting a clarity about the internet of people and internet of things, right? So far for the last couple of years, we are in the era of internet of people, right? So slowly now we are moving into we are adapting to the internet of things as well, with the different types of applications uh, that we are seeing, that we are hearing on the everyday day-to-day life. Now here are some examples which we could say the connected things, right? So you can see the lot of devices over here. We have a mixer grinder, we have a headphone, the gaming console, the camera phone, the LED bulb, right? The microwave oven, television and computer, the scaling machine, tablet, right? The car, refrigerator, the music system, microphone, printer, right? So earlier, uh, we we used to connect internet only to the computers, right? But now when we are implementing an internet of things, right? So we are connecting internet to each and every devices to make our life easier, right? So yeah, this is the internet of things, which we could say connected things. Now let's see why the IoT, why do we need an IoT, right? So basically, as I mentioned, to make our life simple, okay. um, so the best example is, if we are staying in a room, while we are leaving from the home room, right? We need to turn off the AC, fan, or the lights, everything manually, right? So suppose if we forget, so in that case, the power consumption is wastage, right? It has been wasted. So to save that energy, so we can use some automated system, right? So that's a simple example that I would say to make you understand about the importance of the IoT. So we would say, in this hyper connected world, so what is this hyper connected world? It is like, most of us know the GPS, right? So with the help of the GPS, we can track anything. The human, we can track a bicycle, bike, the vehicle, whatever it could be, right? Wherever the current location is, right? So uh, in this hyper connected world, the everything, the whatever the devices that we are using in our everyday life, either it could be the home automation, right? Whatever the electronic systems that we are using in our home offices, whatever it could be, everything is moving into the digital systems, right? So that digital system also having some access to the connectivity with a local server or computers, just to transfer some very minimum informations, right? So by connecting all these devices, we can make some decisions very what we could say. So we could just save some time by making certain decisions automatically without any human intervention. So as I mentioned, so the reason for the IoT is to turn our everyday lives into smart. Okay, so once you go through the different applications what we used in IoT, so you will understand why the real why of the I mean why we need to implement IoT systems. So there are different platforms or different industries that we can use. Okay, so smart appliances, just like our smart refrigerators, smart televisions, everything. Smart security systems, smart home, smart building, smart traffic control systems, and many more, right? So here everything is smart. So the reason behind the smart is IoT. But what do we do with that smart? So it could send some information. For example, let me give you one example about uh, the smart traffic control system. So nowadays we have a traffic control system, right? So do you think that is a smart one? We would say it is an automated traffic control system, right? Because there's some program which has been already made in the control unit, which we fixed in the traffic control systems, right? So there should be certain timer which will be already predefined, right? So that is an automated traffic control system. So then what is a smart traffic control system? So smart traffic control system will analyze the real traffic, okay, and then depends on the number of vehicles on each lane, it will adjust the timer automatically, right? So for example, if we have a 3 lane or 4 lanes, some 1 or 2 lanes will be very busy. Okay, the number of vehicles in one particular lane will be very high, the other lane will be very low. In such cases, if we give 30 minutes or 30 seconds or 60 seconds to every lane, that will be that is not a good approach to manage a perfect system, right? In that case, if we implement the smart traffic control, the security camera which we fixed over there, it will analyze the number of vehicles in each lane, and based on the input from security camera, the control unit will automatically adjust the timer how long the traffic signal should be open, right? So that's a simple example about the automated traffic control system and then the smart traffic control systems. So now you understand the importance of the IoT, right? So by making everyday activities, whatever we are doing in the day-to-day life, to making that into more smarter than what we are having right now. So that's the reason we need an IoT system. And so what is the growth of the IoT in future? So we would say, as you can see, by 2025, right? So the IoT industry will grow between 1 trillion to 3 trillion revenue, right? So this is very huge compared to the last couple of years. Okay, so definitely it has a lot of support, I would say. I'm sorry, just a moment. Yeah. So for example, IoT is not a single domain. So inside IoT, we need to focus on a lot of things. The embedded developer, right? The IoT hardware, IoT software, the APIs, and then the services, the gateway devices, especially the security. Because whatever the devices which we are connecting today over the internet, so we cannot assure the 100% security, right? So there should be a cybersecurity professionals also we need to implement on any IoT projects. So IoT is not a single domain, right? So it includes a lot of multiple domains. So that we will see in the upcoming slides. And so these are the top players in Internet of Things. So I took only very big MNCs. Okay, so to just give you the information about the companies who are working on IoT technology, right? So as you can see, Amazon, ENT, Bosch, Cisco, IBM, Intel, Oracle, Microsoft, SAP, and Siemens. So all these companies are working on IoT. Apart from this, there are multiple companies also which I didn't capture over in this slide. And now, so we understand what is Internet of People, Internet of Things, and then why we need it and what are the companies that are using, right? Now let us see what are the industries can use IoT, right? So there is no restrictions, only this industry can use it. Okay, every industries can use IoT to make their performance a little more better. So this you can say an automotive industry. Okay. And then the e-commerce industry. So automotive, agriculture, excuse me. So agriculture, manufacturing, transportation and logistics, retail, healthcare, construction, and many more, right? So all these industries can use IoT to improve their business. Okay, so I believe you must be heard about the industry 4.0, right? So that industry 4.0, the revolution is, I mean, the next industry generation is just because of the IoT technology, right? We are using the other technologies also, such as the blockchain or even the AI and ML also, right? But the main part of the industry 4.0 is depends on IoT. The reason is the different robots, the different machineries which we deployed in the industry, that needs to be communicate each other, right? So for that communication we need to include the IoT technology. So now let's get into the introduction of IoT. Okay, so some points theoretically, let us look into that. So it simply refers the extending the internet connectivity beyond standard devices. Okay, so just look at the word which is underlined, extending the internet connectivity beyond standard devices. So in this case, standard devices, we could say our desktop, laptop, right? The printers, our mobile phones. So these are the standard devices which we used internet, right? The devices which we regularly connect internet and we are using it. So, but IoT means we are extending the internet connectivity beyond that. So beyond that, in the sense, as we know, beyond the standard devices, it is our television, our refrigerator, washing machine, microwave oven, right? Our coffee vending machine, whatever it could be. So we are just extending the internet connectivity out of the standard devices. So we are making every object or every electronic devices that we are using in our day-to-day life, we are connecting to that internet and we are making some automation process to make us some better decision when it without any human intervention. So we would say IoT is when everyday objects and products are connected to the internet. So everyday objects and products, right, that are connected to the internet. So the objects could be anything, right? It could be any objects, even it could be your table and chairs, right? But it should have some electronic devices that it embedded with some set of sensors and actuators, right? So the electronic devices that can be embedded with some simple softwares and sensors, so that should allows to connect to the network, and that should be capable to transfer the data from the object to the gateway or to the other objects. So basically exchanging information just as a human, how we are doing it in this world, right? So we are exchanging information to the other human, or we are exchanging to the computer. We are just saving some information over the computer. So in the same way, the IoT devices needs to exchange the information to the other devices. So when we say IoT enabled or connected, it should capable of communicating each other, just nothing but exchanging the information. So another point is all these IoT devices can be controlled remotely or even automatically, right? So either the IoT devices can control itself with the help of the data what it receives, and also we can control the IoT devices remotely. So we can just simply turn on or turn off the air conditioners or bulbs, LEDs, right? Before we are reaching to home, right? We can just use our mobile phone. We can simply turn on air conditioner. So that can be done. And let's see some smart devices. So this we could see this. I mean, this is a smart mirror. Okay, the reason the reason behind the smart mirror is, so the moment we get up in the morning, we don't need to pick up our mobile phone to understand what are the tasks that we have today, what are the to-do lists that we have today. We can simply get up and stand in front of the mirror. All the informations which is related to our activities, which is related to the current news, and also the weather condition, and then traffic between our home to our campus, everything will be available in our mirror itself. We don't even need to pick up our mobile phones, right, to check all this information. So that's an example. That's another the thing which smart mirror covers. And we all know the smartwatch, right? The smart watch which could generate the information about the human activity. The same information is available in our mobile phones. So this is comes under the healthcare systems. This next is we have the complete healthcare solution in with the help of the IoT. Okay, so we can monitor the every activity of the patients with the help of the devices what we deployed in our patient's body, right? So even though if the patient is going through some emergency situation in the midnight, so that can be automatically triggered to the hospital, and then the ambulance can be sent to the patient's home, right, without any human intervention. That can be taken care automatically. So the ambulance can reach to the patient's home, and before the patient reaches from home to hospital, the doctors can look at the patient's the history, right? Since all the history were maintained in the cloud server, the doctors can go through the complete history of the patients, and also they can see the current status, which is live status of the patient's health system, right? And before the patient reaches to the hospital, they can make some setup. Suppose if the operation theater needs to be set it up, that can be done before the patient reaches to the hospital. So with the help of these IoT systems, definitely we can save a patient's life. Because think of this, if somebody faces some severe problem in the midnight, we need to first understand the people who are staying with us, right? Then we need to call the ambulance, then we need to reach the hospital, and then doctors will be checking the conditions with, I mean, the patient's conditions with by taking the different test. So definitely that will take minimum 2 hours, right? So we can reduce that time, and we can save the patient with the help of the IoT system. And the other thing is the smart thermostats, which will be useful for our smart home systems. So basically, this thermostat will be controlling all the smart devices that we deployed in our home. And so we understand some fundamentals of IoT, some applications or some industries why we are using, right? Now let's talk about wireless sensor network. So there is a very simple point in this wireless sensor network. Okay, nowadays think about our home. Definitely we have our Wi-Fi router, right? So if we want to connect to the internet, we are not. I mean, we are just connecting to the internet. Either it could be the television, mobile phone, or the laptop. We are connecting over the Wi-Fi, right? That is a wireless network. We are not using any wired connection, right? In the same way, if we want to use any type of IoT systems, IoT projects, we are using wireless connectivity. We are not preferring the wired most of the cases, okay? Because the wireless is the flexible technology which we could connect the devices without with the less amount that we could spend for the network connectivity, right? And also it is flexible to move from one place to another place. So whatever the IoT projects that we are using, most of the things we will be using different types of wireless networks, right? So that's the wireless network. It is the major role which, I mean, which helps IoT to improve further. Either it could be the connection between the different devices, or connection to the each devices to the gateway or to the cloud, whatever it could be. So there are different connectivity technologies. So we know the personal area network, local area network, metropolitan area network, and wide area network. Okay. So all these things we must be aware about at least some basics. Okay. So let me just go through very quickly on these different technologies. So basically IoT itself, we were using different connectivity technologies, depends on the projects what we are using. Okay, so if the project is surrounded within your home, we can go with the Wi-Fi, right? So if it is let's consider a smart building within a campus, if we want to do it, so in that case we can go with the LoRa, we can go with the Zigbee, right? So that's what that depends on the projects what we are using, the technology what, I mean, the connectivity technologies we will be choosing. So we have a technology RFID, NFC, LoRaWAN, Zigbee, Z-Wave, right? Bluetooth, Wi-Fi. And apart from that, if we want to connect the IoT devices across various cities, we can go with the cellular network also, right? So in that case, we cannot depend on the Wi-Fi or Zigbee, LoRa, whatever it could be. So across multiple cities. I'm talking about, because every cities we have a cellular networks. I mean internet service providers, right? So we can just simply buy a SIM cards and we can insert into our IoT projects, IoT devices. We can just use it wherever we are in the world. So there are different connectivity technologies that can be used in IoT systems based on the projects. Okay, so that's a simple information which I want to communicate from this particular slide. And the future network will be it could be anytime, any place, anything, right? So all of you are aware about 5G is it's evolving slowly, right? So from from different countries. So once 5G is uh, completely arrived even in the rural area of the uh, in India, right? So definitely that will be a real milestone for the IoT systems. So as you can see, anytime, it could be anytime, irrespective of the day and night, any place. It's not only the inside home or outside some, any place we can have a connectivity. Anything can be connected, right? Anything, we know the thing is nothing but any electronic devices or any physical objects that is having some embedded software within it that is capable of sensing some information and able to transmit some information to the other devices or the gateway or cloud, whatever it could be, right? So now let's get into the layers in IoT system. We would say there are 4 different layers in IoT systems. The first layer would be the things. Things is nothing but just an IoT devices, we would say, right? So what are the things that we'll be using to collect some information? Okay, so basically, as you can see, we have some industry robots, connected car, and then washing machine, some medical systems, and then the agriculture tractor. So whatever systems, even if you take the smart home, we have a air conditioner and we have some set of temperature sensor which will analyze the temperature from the room, right? And the temperature information will be sent it to the air conditioner. So all these devices which is acting as a sensors and actuators, right? So that will comes under the layer 1 and layer 2. Layer 2 is a gateway. So gateway here is nothing but our Wi-Fi router. Just imagine our Wi-Fi router. So we have a Wi-Fi router, right? So with the help of the Wi-Fi router, we are connecting with n number of devices like our mobile phones, televisions, laptops, etc. So in the same way, with the help of the gateway, we can connect the n number of IoT devices, and yeah, so and we can share the information among the devices, or we can share the information to the uh, cloud also, to the internet with the help of the internet. The third layer, we would say it's a cloud. Okay, so cloud is the place where we used to store all the information which has been collected from layer 1. So layer 1 is basically the IoT devices, right? So IoT devices will be sensing some information, and that information will be sent it to the gateway, and then the gateway will send that information to the cloud. Cloud is the place where we are storing all the information that has been collected by IoT devices, right? And cloud is not only the place to store the information. So it also it is also another place where we used to perform certain analytical tasks and certain automated process. Okay, so since we have a data in our cloud, we can run certain analytical algorithms in the cloud itself with the with the help of the different cloud services which has been provided by different cloud service providers. Okay, so cloud is the place where we used to store the data, where we used to analyze the data, and we will be taking some decision in the cloud itself, and then we will sending the information back to the IoT devices. Okay, so just okay, so the the next layer is then analytics. Okay, so let me give you a simple example from the home automation itself. Okay, let's assume we have a temperature sensor and then we have a air conditioner. So temperature sensor will be sensing, both comes under the layer 1 IoT devices. Okay, so the temperature sensor will be sensing some information and it will be sending to the gateway. From gateway it will reaches to the cloud. The information will be stored into the cloud server, and at the same time the analytical engine which we deployed in our cloud server, that will analyze the real-time data. Okay, and so since the analytical process, everything is done in the cloud, so it will analyze what is the temperature, what is the current temperature. Okay, just consider if the temperature is greater than 20 degree, turn on the air conditioner. The small rule we might be fixed in the analytical engine. Okay, so the analytical engine will be monitoring the every data, every real-time data that comes from the temperature sensor. It will just validate if the temperature is greater than 20, immediately it will trigger an alert. Okay, trigger an action to the air sorry, trigger an alert to the air conditioner to turn on the air conditioner when the temperature reaches the 20 degrees Celsius. Okay, so that trigger, that action will be performed with the help of the analytical engine. So imagine in this analytical engine that the action can be done. Okay, it checks the temperature, it comes greater than 20 degrees Celsius. So then the action needs to be uh, the, the action what it needs to take and care is turning on the air conditioner. So that action, the analytical engine will send it back to the gateway, and the gateway will send it to the air conditioner, right? So the air conditioner will listen that action, and then it will turn on automatically, right? So imagine this process is taking automation without any human intervention. So the only part is we are having some intelligence in the cloud server. So with the help of the intelligence, we are turning on the air conditioner automatically, right? So I believe you must be understanding the layers along with the example what I had just given. Now let's look into the some explanation, some information about the each and every layer. Okay, so as we discussed, IoT devices is just a piece of hardware, and that has some sensors and actuators which will be sensing some information from its surroundings. Okay, and then it will transmit the information to the other devices or to the gateway. Then it goes to the cloud. It depends on the projects what we are implementing. So here you can see some set of different sensors what we have, uh, current sensor, proximity, motion, and then the ultrasonic sensor. And here there is an one IoT node which we listed here. So this node which has an inbuilt Wi-Fi. So this is just a microcontroller. This will be connected to the different type of sensors. Whatever the sensor is sensing the information, that information will be passed to the microcontroller. From microcontroller, right, which is nothing but our IoT device, right? So this IoT device will send the information to the gateway or to the other device or directly to the cloud. Depends on the configuration what we do. So there are mainly three things that any IoT devices will do. The first thing is sense and record the data from its atmosphere. Second thing, it is performing light computing. Then it connects to the network and share the information what it is sensed. Okay, temperature sensor, the duty is it is sensing the temperature from its atmosphere, right? It performs some light computing in the microcontroller where it connects, and then the microcontroller connects to the network, and it communicates the temperature sensor what it just sensed. And the second layer is the gateway. So as we know, gateway is just like our Wi-Fi router, right? So just like how we are connecting other devices, I mean the mobile phone, laptops, televisions. So gateways act as the same way. Apart from this, gateway itself, whatever we are using in our IoT, right? So the gateway itself, it's a mini computer. Okay, so it's basically handles the connectivity between device to device or device to cloud. Okay, so as I mentioned, a temperature sensor doesn't need to uh, transfer the information every day, every time to the cloud. It can automatically sends the information to the gateway, and gateway itself can take a decision. Okay, if the gateway is the capable to take up its own decision, depends on the data what it receives. Then the gateway itself can trigger an alert whether to turn on or turn off the air conditioners. So basically the gateway is responsible for device to device communication or device to cloud communications. So it's typically a hardware just like our Wi-Fi router which we are using in our home. Then let's get into the cloud. Okay, so cloud computing, it has the lot of computing services. So most of the people are thinking about cloud is only to store our data. So it is not, of course, it's true. We are using cloud to store our data. For example, if you are using Google Drive or Google Photos, whatever it could be, we are using those services to store our data. But apart from this, cloud is providing a lot of services. Okay, the best example is Gmail. Gmail, it's a cloud service, right? We don't need to install anything in our machine. It is a cloud service, right? So it is a software which has been developed and maintained by Google itself, right? So we are just accessing the service. So I'm just giving an example of the cloud. So cloud computing delivery of computing services that includes the servers, storage, databases, networking, software, analytics, and intelligence. So the one which I referred here is the Gmail, right? So that is a cloud software service, right? That is a SaaS, software as a service. There are multiple other services that cloud computing, cloud service providers are providing, okay, such as the including servers. Okay, so suppose if we want to start a company or if we want to start an organization, we need to maintain certain servers that will be maintaining our records or our some simulations or whatever it could be, depends on the internal server. So in that case, we need to dedicated space, dedicated hardwares, networking professionals, internet connectivity, air conditioner, uninterruptible powers, all those things, right? We need to take care of a lot of things. If we go for a cloud, we don't need to worry about anything. We can simply purchase a cloud server. We will be getting a complete access and we can access it. The another advantage is we can use the cloud servers wherever we are in the world, right? So that's a storage service and databases, networkings, analytics, and intelligence. There are a lot of services which cloud service providers are providing. The company who are providing the cloud services, right? It could be any service in the cloud. So those companies are called cloud service providers. So I believe we all know these companies: AWS, which is Amazon Web Services, Google Cloud Platform, and Microsoft Azure. So these are the top companies who are providing various cloud services from different industries, different domains. And these are some other cloud service providers. So some providers, they are offering the initial the free services as well for a certain period or only for the certain services. Then data analytics. Uh, so the reason why we need to analyze our data is basically we are generating very huge amount of data without even our our basic knowledge. Okay, for example, I'll just give you one simple example. Okay, so everybody are using a smartphone nowadays, right? So do you remember how many times did you unlock your mobile phone yesterday? Or do you remember how many times that you have opened your WhatsApp or your Facebook or your mail, whatever the application it is? So do you remember how many times that we opened, that we unlocked our mobile phone, that we opened each applications? We don't know, right? We cannot count that every time whenever we are opening, we are unlocking. We don't remember that, right? But our mobile phone remembers that. Okay, so if you go to settings, go to apps and some places, okay, in the apps and settings, if you go there, you can check all the information about your activity with your mobile phone. Okay, for example, how many times you unlocked, how many times you opened particular applications, and apart from that, how much time you spent with your mobile phone, which is nothing but how much time your mobile screen was on, how your mobile screen was used. So every information is captured in our mobile phone. Every information is captured by our mobile phone, but we don't know how many times we unlocked our mobile phone each and every day, right? So this itself is a data. Now imagine how many people we are in the world, everybody having a smartphone, right? So all these data, it's very huge, correct? So what is the use of storing all these data? That's a question, right? Of course, we are having some system, we are storing, we are capturing the data, we are storing it. But what is the use of storing these data? For example, a simple example, imagine a smart home example itself. Okay, so we are having a temperature sensor and air conditioner. So if we make it implement IoT in smart home, we will be capturing the data and storing into our database. So imagine you implement it right now. Okay, so December 2021. So December 2022, if you look back the implementation, if you open your database and see, you will be having a temperature data of last 1 year. right? So after 10 years, you'll be having a temperature data of last 10 years. So what do we do with that? So we need to do some analysis on that. Okay, some simple example. I'll give you another example. Definitely you will understand. Okay, let's take an example of the examination results. Okay, so each and every student, it's only about their results. But think about from the faculty perspective, from the section wise or the department wise, right? So that examination results is very important for them, right? So they need to do a simple analysis of the each and every subject, right? What is the top mark from the subject? What is the percentage of the each and every subjects, whole subjects, and then department wise, and then it goes to the institution wise, and then it goes to the university wise, right? So that is a simple analysis, right? So simply we are getting the examination results, we are keeping the data in our Excel sheet, but we are not doing anything, right? So that doesn't gives us the basic information about how we performed last year, how we performed this year, right? So to understand our performance, to measure our performance, either the individual performance or the overall group performance, right? So we need to perform some small amount of analytics. Okay, so I believe you must be understand the basics of analytics. Now let's get into an IoT analytics. As I mentioned, as a single user, we don't know how many times we opened our mobile phone, right? That's the just think about an IoT device, a single IoT project. If it is simply home automation, we must be implemented a sensor, refrigerator, um, what are the LEDs, bulbs, and then the air conditioners. So minimum 5 devices or 10 devices. Okay, so minimum five or 10 sensors which we implemented in our smart home. Okay, so within 1 year, all the 5 sensors will be generating large data, right? So what are we doing with that large data? So we need to perform some analytics. Think about very huge project, either it could be the smart city or smart agriculture, whatever it could be. So if it is 100 sensors or 1,000 sensors within a single project, all the 100,000 sensors will be generating sensing the information for every 2 minutes or every 2 seconds or every 5 minutes, depends on the projects. Okay, that we will be using the how frequent the data needs to be generated. So all these data we are storing into a server. So by simply storing the data, that doesn't gives any information to us. If we perform an analytics on that data what we stored, we will understand the up and downs, right? And we will understand how the behavior data behavior is. So that's the importance of an analytics. uh, yeah, so you can see, just the objective is just to discover some useful information. We have an examination results, we need to discover some useful information, right? So that to discover that, we need to perform some data analytics. So just like if you might have seen news and even crickets also, so they were just showing some analysis graphs, right? So that's a simple example. And the role of analytics is gathering insights, generating a reports, perform market analysis, and then improve the business requirements. So just consider the same examination results. We are gathering the insights. We are just looking the what is the hidden information which is behind the numbers, right? Numbers in the sense just a marks, and then we are generating the reports. Sorry. So and then we are performing the market analysis, how we are performing, how the other person, I mean other institution or other campus is performing, all these are the market analysis, and then improving the business requirements. So what we need to do to improve the next step, improve the further performance. And so we understand all the 4 layers. Now this is a complete IoT architecture, right? This first thing is the devices, which is the layer 1 we could remember. So devices is nothing but sensors and actuators. And the second part is the gateway. The third is the IoT cloud platform. The fourth place is the analytics. Okay, so all the devices will be sending the data to the gateway, to the finally it reaches to the cloud. In the cloud, we will be performing certain analytical operations. It shows some dashboards, and even we are using the mobile applications to look at the informations from the cloud, just like the smartwatch. So this is the overall architecture. Now let's see the different applications in IoT. So we have a smart city. Smart city in the sense it doesn't have a single application. It needs to have a multiple applications. For example, smart home, smart grid, smart healthcare, smart mobility, smart security systems, everything. So all together comes under smart city. Then smart grid. Okay. So the reason why we are using smart grid is, so basically we can reduce the wastage of the electrical, and whenever we are reducing the wastage of the electric power, so we can reduce the cost also, right? And industry 4.0. So as we know, industry 4.0, it's a next revolution for the industries, right? So this industry revolution is, it's happening, the primary part of the industry 4.0 is internet of things. Along with this internet of things, there are different technologies also. As you can see, it's a cyber security, cloud computing, augmented reality, robotics, artificial intelligence, and machine learning. So all these technologies together we would implement in the industry 4.0. And connected car technology, right? So with a simple GPS, we would able to track where our vehicle is, right? Of course, that can be done. But when we are talking about connected cars, that's not only with the GPS. It's about the multiple systems. It's about the connected traffic, the infotainment, and then the automobile diagnostics. When it shows, it says automobile diagnostics, some sensors we would be there in the car engine. Okay, that sensor will analyze the engine sound. Okay, that will be, that information will be sent it to the manufacturer cloud server. So in the manufacturer cloud server, they will be running some simple analytical process. Okay, so when the car engine sounds goes wrong, okay, the system which is there in the manufacturer side, it will understand some problem in the particular engine. So immediately the manufacturer will trigger an alert to the respective owner, right? So before some engine problem happens while we are driving, we could get a notification says that there is some problem in your engine. It could fail within 100 kilometers or something, some information, something like that. So before something really happens bad, we could get a notification, and we would take our car to the nearby service centers and we can get it sorted, right? So this is automobile diagnostics. So before some problem happens, we could just solve it. And definitely the IoT is very much useful for the supply chain and logistics and healthcare. So we had seen an example in the beginning itself, right? How we can save a patient's life with the help of IoT. And then the agriculture, right? So we could analyze the soil quality, soil moisture. Based on the soil moisture, we could just pass the water, all those things, and we could just understand the quality of the soil, and then what type of plant we can grow in that particular soil. All these things can be done automatically by with the help of the IoT systems. And then the e-commerce. So we know everybody right now, we are using a different e-commerce platforms to purchase anything. And with that note, I would like to give an additional information says that the IoT, as I mentioned, IoT is not a single domain. It is a multiple domain which includes embedded systems, right? And then the system softwares, the gateway devices, the cloud services, and also the network engineers, cyber security engineers, along with the cloud engineers, the machine learning engineers, artificial intelligence, with data analytics and data science, right? So at the left side, you can say domain-based different roles which placed in the IoT. So embedded developers, networking professionals, programmers, cloud application developers, mobile application developers, right? Because in the smartwatch, we are tracking the information, we are seeing the information over the mobile phone. Data analytics and data science, MI and AL, I mean ML and AI engineers, right? And if you take one specifically the hardware and networking, hardware and networking itself, there are a lot of job profiles. So I have taken very few on the right side. So embedded hardware engineer, embedded software engineer, system test engineer, embedded system designer, embedded wireless firmware engineer, IoT developer, IoT engineer, IoT designer, IoT platform application developer. So each role specify its own individuality in the whole IoT domain, right? So IoT, it's not a single domain. It has a multiple domains which includes it. So each domain have a multiple job vacancies. So with that, I would like to share another information with all of you at Tuple. So we have a solution for IoT. Just give me a moment. I hope my screen share is visible. Sorry, is it
Yes.
visible? Oh, okay.
Yes, I think it is coming. है ना? It will.
It shows true IoT.
Hmm.
Is it visible, sir?
No, no, sir, no.
Okay, let me reshare.
Yes.
Is it
Yes, sir.
visible now?
Yeah, yeah. Now clear visible now.
Yeah. Okay, sir. Thank you. So I would like to just introduce our product, which is True IoT platform. Okay, it's a pure development platform, especially for the students who can learn more about IoT technology. Okay, I'll just give you a short overview about the product. So in this product, what we have is we are covering the whole layers. I mean the whole system, whole architecture of the IoT. Okay, so basically we are providing a 20 plus sensors and actuators, and we are providing one gateway. Along with that, we are providing an integrated node also, standalone integrated nodes, which some nodes which is having a touchscreen capability also. So along with this, we are providing some AWS credentials. We are having a separate individual documentation with some 40 plus exercises. Okay, so the exercises which will help the students to learn from scratch. For example, how to get a temperature data from a temperature sensor. So that is a beginner level exercise. That's we used to say level 1. So like that, we have a multiple sensors like the solenoid valve and the stepper motor. We have the relay. We have 20 plus sensors and actuators. So initial level 1 exercises will covers how to get the data from the each and every sensors. So by experimenting level 1 exercises, the student will understand how to get the data from the real IoT devices. And the second level is we are just combining multiple sensors. For example, taking a data from temperature sensor, turning on the LED, right, or turning on the air conditioner. So these combinations taken care in the level 2. Level 3 with the gateway implementation, and level 4, which includes the cloud also. So here, uh, we are providing a complete IoT experience with all the levels of IoT architecture. So as I mentioned, we are providing a hardware and also we are providing a software also. We have a True IoT software suites, which includes the pre-installed development environment and subsystem softwares, which students can learn with the help of this True IoT software. Student can learn how to connect, how to program the IoT hardware, how to collect the data, all those things. And we are providing a training also, and we are having a certification programs too. And we are offering the web portal for this True IoT also. So the simple analysis, competitive analysis with compared with the existing product from some others and with Tuple. So at Tuple, we are providing end-to-end technology. It's like a one-stop solutions for the complete IoT architecture. We are offering training too. We are offering the support especially, and we are providing a certification programs too. So as you have gone through the so this, you can see this is the complete one kit of our True IoT product. So this includes the one which you can see. This is the IoT gateway which support the 7-inch touchscreen display. So basically, as I mentioned, 20 plus sensors. We will be implementing individual projects such as the agriculture projects or healthcare projects or smart home automations. So each can be done with the help of this True IoT kit. So at the same time, the information can be passed to the gateway device, which is listed over here. And from the gateway, we are passing the information to the AWS cloud. And then the decisions, the analytics engines will be running on the AWS. The decision can be taken based on the input data. Finally, the trigger can happen to the IoT device itself, just like how we were turning on the air conditioner with the help of the temperature information. So this is the complete IoT solutions which we are providing at Induper. So that information which I would like to convey. So with that information, I thank you everybody to providing such a wonderful opportunity to present about Internet of Things and its applications with all of you. So thank you, sir. Thank you so much. So if you have any questions, we are welcoming the questions.
Thank you, Natarajan sir, for giving us such beautiful session and give the project details on information related to IoT. Sir, I think in the chat window, yes, sir is also share the details, and if there is any query related to this session or the some project, we are definitely contact you. Thank you, sir. Thank you very much.
Thank you, sir. Thank you so much. Thank you, SKG. Thank you.
Okay, sir.